So hello everyone. So let us see the electromagnetic flow meter. So with respect to sensors and transducers, how it works, the construction part, everything we'll discuss now. So coming to this electromagnetic flow meter, so where the name itself it says that it's something the electromagnets are used to determine the flow, the liquid flow, what is the pressure, how it is flowing, whether the direction of flow, everything can be determined using the electromagnetic. So coming to the construction part, if you look at here, so as I mentioned, the name electromagnet here. So they make use of electromagnet which consists of a north and south pole magnet. So this is a permanent magnet here, and within the magnet, in between this north and south pole, it consists of an insulated conduit, which you can see the cross section of the same over here. So this is a conduit which will be present over here. So within the conduit, the fluid will be flowing. The fluid flow happens within the conduit here. So this conduit has been connected through the electrodes, which you can see the either side of the conduit. The electrodes has been connected, and these electrodes have been given to the a potentiometer or a multi-voltmeter. It will be given for that for a measuring purpose. So this is the construction part with respect to the electromagnetic flow meter. So as I mentioned, this is a PM, that is a permanent magnet, and this is your display. So where right now they are using a multimeter or a potentiometer to display whatever the voltage it has been generated because of the fluid flow which is happening within the conduit here. So let us see how actually it works here. So initially the conduit carries a fluid which will be flowing in one direction. Let us assume the direction right now, the arrow mark which have been shown here. So let us assume the fluid is flowing in this direction. So now when this conduit has been placed within the magnetic field, the magnetic flux lines will be flowing from north pole to the south pole. So the flux lines will be traveling over there. So whenever the flux get cuts using this fluid which is flowing here, because of the cut, what happens, the EMF will be induced within the conduit. So where the electrodes are present here, which you can see here, these electrodes, what happens, it will measure how much amount of voltage has been induced within the conduit. So this voltage will be measured and it will be connected to a multi-voltmeter or a potentiometer. So because of the disturbance in the magnetic field, the EMF will be induced in this, that EMF will be measured here. So suppose say whatever the pressure is present here, the voltage which is being generated here, which will be directly proportional to the flow. How much amount of flow it is happening within the fluid, the pressure, everything can be determined. That will be proportional to the voltage generated here. Suppose say the direction is reversed now. The direction of fluid is in a opposite. In that case, I need to interchange the direction of this electrode. If I interchange the direction of electrode here in this way, if I connect, so then the reverse flow also can be measured. In that case, once again I can measure the voltage generated, voltage which will be proportional to the flow. This meter will also help to determine the direction, whether it is in a forward direction or a reverse direction, that also can be determined, and also it will be used to measure the flow, what is the pressure which will be transmitted within the conduit. So both can be measured. That is the advantage of the electromagnetic flow meter. So this is where the EMF, as I mentioned already these things have been discussed here. Basically the fluid will be the fluid which will be transmitting here within the conduit, which will be of a conducting type. So it could be of your slurry type or sludge or any electrical conducting fluid. That is the main drawback here, we can say. It will be only this flow liquids are present, then only it will be able to measure. The EMF which will be induced in the electrodes, so that is given by this equation, E is equal to BL by 10 to the power of 8 volts. P is the magnetic flux density per volts per centimeter. L is the length of the conductor, and V is the velocity of the conductor in centimeter per second. So this voltage E will be proportional to the fluid force or pressure which will be present over there. This is how it will be measured here. So finally, this is the flow rate. The flow rate also can be determined. I can determine Q is equal to pi by 4 d square V. So finally, the induced voltage E will become as, so 4 QB divided by pi d into 10 to the power of minus 8 volts. So Q is directly proportional to the induced EMF here. So whatever the flow rate, which will be directly proportional to the induced voltage. So this induced voltage is directly proportional to the force or pressure which is flowing within the conduit pipe. So this is how it will be, this kind of a meter will be used to measure here. Coming to the advantage and disadvantage part, no obstacles in obstruction to flow here. One case, can handle slurry, grease material, liquid containing suspended materials, high accuracy and reliability, the output unaffected by the change in the characteristics, the output voltage is linear with respect to the flow rate, bidirectional flow can be measured, forward and reverse direction both are possible, the mass flow rate can be determined, so the Q can be determined from, we have been seeing the formula. The output voltage of these meters is proportional to the average velocity. So disadvantage, obviously it has to be, operating cost is very high because of it has to handle heavy slurries over there. It is limited to the conducting type of a fluids only, and this must be full of all times because it has been seen the velocity of flow is to the volume of flow rate. The conduit should be always full. It should not be half of the conduit or anything else. The conduit should be always a full conduit, so where it can flow easily. And coming to application, so this can be used for materials like corrosive acid, cement slurry, sewage, paper pulp, detergent, etc., which can be present in difficult handling problem. So these are the advantages and disadvantages. So, thank you.